Hi, so in this video I want to introduce PoseNet, which is a machine learning network that uses your nose to draw. So I'll go over some of the basics of how you use PoseNet, which is what we use as a machine learning library using ML5, and then also using P5 to actually draw things on screen. So let's get started. I'm going to start with a new blank project just to give you some idea of how we can work here. So I'm going to make a new folder and call it PoseNet. In this folder I will open in Visual Studio Code. So I'll make a new window, drag it over so you can see, and then open this empty blank project. So as you can see, there's nothing here. The first thing I want to do is start with the documentation. So there's two pieces of documentation that I will be using. One of them, or two pieces of software. One of them is P5. And the getting started here is really useful because it shows you how to set up these things. And then there's the download link, I think, as well, which gives you the links. We're going to start from scratch, but I just want to show you how that works. You can also work with the P5 editor if you want, but this is just starting with Visual Studio Code. The other piece of software that we need is ML5, which is a machine learning library that is available for JavaScript, and it makes it really easy to use machine learning libraries, existing machine learning libraries within your system. And the one that we're looking for specifically is this one called PoseNet. PoseNet allows you to track your entire skeleton, but we're only interested in the nose, so we can take out part of that network and actually use it. There's some good documentation on PoseNet as well. So to get started, what we need is one file, our index.html file. This is our primary file, and in Visual Studio Code I can now type exclamation mark and press enter to actually have that complete the first part of my document. And I'm going to call this PoseNet. In the body there are a couple of things that I need. The first thing that I need is some links to the scripts that load P5 and ML5. The best way that I've found to do this is to use unpackage. And the way that looks is just to provide a URL with the package itself. So I write script : source, type tab, that completes the HTML for me. And then I type https unpackage.com/p5. And that loads P5 for me. So going to that link, and here you can control click to actually open it. You see that it loads this full library with the latest version. Same thing we can do for ML5, so we just copy and paste this. And here we use ML5. So now these two libraries are loaded, and we can check or verify that this works. Maybe we can also add something here. We're going to, in the body, just write a paragraph that says loading. We'll need that paragraph later, so that's useful to have anyway. We'll save, and then we'll use a live server to actually preview our document here. So I'm going to go to View, Command Palette, and then use Open with Live Server. If you don't have this, you go to the extensions and install this extension, which is called Live Server. So search for it and then press Install. That will give it here in the Command Palette view, and then there's Live Server, Open with Live Server. That loads your default browser with the script, and as you see here it says loading. Now nothing's actually loading, so don't wait for this because we want to replace that text later. What we do want is the inspector tool, so we're going to right click, open the inspector tools, look in the console, and you would see this message meaning that ML5 is loaded, and they refer to you to the community statement and the code of conduct. Here we see our elements, we see that we have our paragraph, we see that we have our two scripts here loaded, and then there's some code that's injected by the live server that allows us to reload the code whenever we change it in Visual Studio Code. We don't really have to worry about that. Let's go back here. P5 requires two functions for us to work. One is setup and one is draw. So we're providing these functions here. And the way that that works is we're going to write a script tag, and that script tag will have all of its code in line. So in setup, write function setup, we're going to create a canvas. I have a default full HD screen here, so I can use a canvas of 800 by 600. If yours is smaller, you might want to use 640 by 480 or some other size. In draw, just here, we can test out something. We can just draw a rectangle and provide an X, Y, width and height. So I like to do 10, 20, 30, 40, just to see if we get a rectangle on screen. Going back to our browser, we see that we have our rectangle drawn, and we see that it still says loading. And it says loading because it's just a message that we need to disappear. It could say anything, basically. If you look at the page, and I press the element inspector here, you see that the main element is just here, but there's no styling. What we really want is our canvas to be to appear in the middle. So we're going to add a bit of style here. Basically what we want to do is we want to center all the elements on the page. So we're going to select our body element and say that we're going to use flexbox, and that allows us to center elements on the page. We want to give it a height of 100 view height, which means that the body will take up the entire screen. And we want to center everything on screen. We can do that using two lines: justify content, center things on the primary axis. In this case it's horizontal, but we'll change that in a minute. And then align items, center things on the secondary axis, in this case the vertical axis. So looking now, we see that we have our loading here and our canvas here. Note that they're next to each other, they're side by side, because our primary axis now goes from left to right. This is our default way that Flexbox uses layout. That's not really what we want, so we're going to specify direction. If we set flex direction to column, that means that all the items will appear below each other. So saving, going back, we see that we have our paragraph here centered, and then our canvas also centered on the screen. So this is much nicer. This is what we want. I'll do a little bit more of styling later, but this is enough to get us started. First, what we want to do is actually get our video here. And to do that, we're going to use a video variable. Now, because we need access to it from the setup and draw, what we're going to do is define it above here. And that allows us the browser to keep using that both from the setup function and the draw function. We're going to say create capture video. So that's going to capture video for us. And then we're going to set the size of that video. And that's going to be set to width and height. Width and height are automatically defined by P5 for us based on the size of the canvas that we defined here. Now, what we can do in draw is once we have that video is actually draw it. So we can say image video 00. So we start at the top left with height. So draw the entire video on screen. Now it asks you if I want to use my camera. I'll allow that. And here we see the video. We actually see it twice. And the reason why is because we also have this video element inside of the page. That video element appears the moment that we say video create capture. That creates a video tag for us, this one. And that gets set to this media element. Now, we want to hide that video. So we can say video.hide. And it's going to remove the video. Just one of them. So the one that's remaining is the one that's inside of the canvas. So this gets drawn. Okay. And now we want to initialize PoseNet. So to do that, we're going to make another variable to allow it to access it from both setup and draw. Here we're going to say PoseNet equals ml5.postnet. And if you're a bit confused with the parameters here, remember there's awesome documentation for PoseNet, if we can find it here. So this explains the entirety of PoseNet. Specifically, this is the part that's interesting for us, because this is the part that we want. We want to load a video, which we have, and there's a function that we get called, so we refer to that function that says, okay, now the model is loaded. And this one is the one that actually removes this text. So I'm going to refer to the video as the source of our PoseNet, so what PoseNet can use to detect our skeletons. And then we're going to say, call the function model ready, which I don't have yet, to actually remove that line of text here. Okay, there's one last thing that I want to do, and that is that PoseNet actually sends me a callback every time I get a pose. So every time I know where something is on screen, basically every video frame, it's going to send me a message, and I want to capture those poses, and I want to store them in a variable as well. So the way that that does it is it says PoseNet on pose, so whenever we get a pose, we get some results. And again, this is a function. So this weird syntax is JavaScript's way of saying, okay, now there's a function that takes the results, and what do you want to do with it? Well, we can log them, but in this case, what we want to do is make another variable, poses, and poses is going to be set to results. So basically, this stores the results in poses, so that allows us to access them from both setup and draw. Cool. Now, we don't see anything, but we can at least check if something crashes, and this is useful because now we see a crash. So remember, this is why we want to leave this open, because it's going to keep saying loading, even though it's not really loading anything, because we have this error here. So if we see this little error here, we can go to console and see what the problem is. And we can read it. It says uncalled and promise reference error, model ready is not defined at line 34. So going to line 34, we can see that we have our model ready, but this function that it needs to call is nowhere to be found. So we give this a name. It's up to us to choose this. We can also call it on when we're done or whatever, but we still have to write that function. So let's write it here. And what do we want to do here? We want to basically remove this loading thing. And in P5, there's also a way to select elements and remove that. There's a HTML and a select function that allows us to select both of them. So for that to work, we need to give this thing a name. So we're going to call it an ID, an identifier, saying status. So this is a status element. Again, this name is something that we pick. Now we can select that status element using hashtag select, and the hashtag actually refers to the fact that this is an ID. This is just a convention in JavaScript, and HTML we don't actually have control over that. And now we can say .html, and we can write something here. Model loaded, for example. So now this loading text will change to model loaded the moment the model is loaded. We don't actually want to see anything though, so we just keep this empty. So there's no text here. Now, what do we do with draw? What do we do with these poses? Well, first off, let's check if we actually have one. So note that this is a plural. PoseNet actually can detect multiple skeletons, multiple poses at the same time. So poses can be a list, and we can log this. Now, this is going to be a lot of information because it keeps doing this every frame over and over, but let's try it just to see what we get back. So note that it starts here with undefined. So in the beginning, the first frames that we draw, there's not going to be a pose loaded. So we have to be prepared for the fact that there are no poses. And a way that we can solve this is by setting poses here to an empty array. In this case, there are no poses loaded. It's a list with 0 items. That allows us to check if we have a list, and then check the length of that list. And if that length is 0, it means we don't have any poses. So this is really useful for us. So now it starts, you see it starts with an empty list, and then we get a list. Let's go back up. We get a list with 1 item, and this is the pose. And there's a bunch of stuff in there. There is the skeleton, which we don't really care about. As you can see, it's not complete because I'm not fully in the frame. My body's not fully in the frame. But this is the part that we are interested in, the pose, because that contains the X and Y positions of left ankle, left ear, left elbow, left eye, and here the nose. This is what we want. Note that it has an X and Y value that correspond to the X and Y values of our canvas, and a confidence level, saying how sure it is that this is the place where the nose is. For example, it doesn't really know where the left hip is because that's not on screen, so it can only guess where that position is going to be, but it has no clue. Okay, so that's a lot of information, and I see it's a lot of deep information. So how do we get that out? One way that I like to play with this and is then the moment that I have a skeleton that I want, is that I try to invoke the debugger, and that's going to stop the code at that point, and I can play around with that. So let's try that out. I'm going to say if poses.length is bigger than 0, and actually this part can be removed, but this is sort of clear. So the moment I have a pose and it's more than 0, so I have detected somebody on the page. Now I'm going to call a debugger, and the debugger, I'm just going to close the window here. Let's get rid of that noise. So now you see that the code actually stops in the debugger. So it stopped at this line. This is what we wanted to do. The code has stopped. Note that the screen is also stopped because there is no video now playing. So now I can look at that poses variable because it's available. I'm running a code at the moment where that code stops. As you can see here, so I can see these poses and I can see that there's one of them. So I can say poses 0 is going to be the first pose element in that list. Okay, so that has a pose and it has a skeleton. I'm interested in this pose because I'm interested in the nose, so I use the arrow key up to get that last line again. Poses.pose. Okay, and now I can probably find out the nose. Cool, and now I can see the X value. So this is the information that I want. This is what I want to get out of there. So I'm going to make a function here. I'm going to call a function here, which is called drawNose, and that's going to call poses0.pose. So that's the information that I pass on here. So what drawNose takes is a pose, and it's going to use that pose to actually draw, from that pose, take the nose item and draw that. So I'm going to set a fill color to red, then use an ellipse to draw. And an ellipse by default draws from the center, which is exactly what we want. So pose.nose.x, pose.nose.y. I don't have a debugger statement here, so this should work. I probably want to remove this console log as well. And now going back, reloading our page. We want to see something happening, but as you can see, it's not drawing anything, so it's not really doing what we want. Let's check why that is. And a way that we can check is to make sure that this function is actually running. So I can write debugger here. As you can see, it stops. And now I can verify, okay, there's a pose, there's a nose, and that has an X value, or it should have an X value, and it should have a Y value as well. So that's kind of weird because I expect this to actually be drawing that nose for me. Let's get rid of that image for a minute here. Refresh. Do we get something here? No, we don't. That's kind of weird because I tried this before and I actually saw this. Oh, but we have some parameters missing. So ellipse, let's go back to our documentation here. Ellipse actually takes 4 parameters. And the first 2 are X and Y, and the last 2 are the width and the height. We only have to specify 1 actually. So we are going to set a size here of 8. Otherwise we get a size of 0, which is what we got before, and nothing actually works. Cool. Let's draw the image again. And as you can see, it follows the nose. It's kind of choppy, but it follows the nose, and it works really well. If I hide that, you see it has much more trouble trying to find that. So its confidence level is going to be lower because it doesn't know where the nose is. But this works really well, as you can see, and I would be able to draw here. Now, the way that I keep drawing here is by removing that image. If I don't draw the image on top, then I don't actually see the image. It doesn't automatically, P5 doesn't automatically clear the canvas, so I keep seeing this. We can also remove this rect, by the way. And now you can see I can draw here. What you don't see is that this image is actually mirrored. So I actually want this to be happening in reverse. So so the window is actually on that side, but if I point to that side, it needs to be flipped. So there's two things that I want to do here, and that's basically use a scale to flip it, and then translate width is going to flip that image. This might be confusing, but these two lines basically flip the image horizontally. So this looks better to me, because now if I move to the left, the image actually moves to the left. If I move to the right, the image moves to the right. So this makes much more sense. It allows me to give much more control. Now, as I said before, I don't want to see the image, but as I showed you in the final one, here I actually see the image. So how does that work? Well, there's two things that we can do. Or remember that we hide the video image here. Actually, if we show this again, this video is actually a separate layer. Now, what we want to do is we want to have this element and this element be on top of each other. And we can do that in HTML using a bit of styling. So this element, if you look at them side by side, is the main element, and this element is the video element. And basically we want the two to overlap. So in the style, what we're going to say is say video is position absolute, and main is also position absolute. This works. I mean, they're on top of each other. The only problem is that the video is now on top of the canvas, so we don't actually see what we've drawn. So let's move that main up by setting a Z index. The Z index basically changes the layer, so it says which element goes on top and which element to go to the bottom. Now, remember that we flipped this image, so now our video tag is not actually flipped, but our canvas is flipped. So this one is flipped, but the one on the behind it is not. So to fix that, we're going to transform this video and also flip it. So here we write scale -1,1. Remember, that's kind of the same thing that we did here. So we flip our video image, and now the two are on top of each other. Cool. Now, one last thing, and it's to get rid of the choppiness. As is shown in this example, this is much smoother. And the way that that works is using a simple mod trick that we're going to do, which is that we're going to keep a certain position, let's say the previous position, and then with that previous position, we're going to gradually add the new position. So it moves gradually to that new position every time. And the way that that works is we're going to take the old position, the new position, subtract them from each other, and take the difference and sort of apply that difference gradually. That sounds kind of complex, so let's see it in action. We're going to make another variable, nose x and nose y, and that's by default is going to be set to the middle of the screen. So width divided by 2, height divided by 2. We have to do it here and not here because we don't know what the size of the screen is unless we do create canvas. So it has to happen after create canvas. And now whenever we draw the nose, we don't actually draw this directly. Instead, we're going to do this calculation. So we want to change this to nose x, nose y. Now, of course, the original or the pose information is not contained anymore. So now it will only draw this one dot, but it never changes because the nose x and nose y don't change. So let's do that now. So nose x, we want to add it with the difference between the pose and the new one. So we take the pose data, pose nose x for example, and subtract nose X from that, so the original data. So this is the difference between where we want the point to be and where the point is right now. And then if we do it like this, it immediately jumps to that nose position. So if we do it like this, same for Y by also, then all we've done is basically written the same code as before. So we've taken the difference between the new position and the old position and added that to the old position. So basically this means nose X equals pose.nose.x. That's not really useful, but now what we can do is we can multiply this with a certain value. We can say multiply this with 0.01, for example. Note that if we multiply this by 1, we get the same result. So 0.01 is a small difference, a small way to that original value, or to that new value. And now if we see it, we see that it gradually, very gradually moves towards the position of that nose. And as you can see, it's a bit too slow maybe, but of course we can tweak that. We can make this 0.1, which means it goes 10% towards the new position every frame. Oops. So let's save. This is what I had in the original one. It looks much better. It's much snappier, but it also gives you some smoothness here over the image. As you can see, my camera has some trouble keeping up with the autofocus, so you might want to change those settings in your camera. I didn't, but that might be useful. But this is what I wanted to show, which is PoseNet, which is a way to be able to draw with your nose.